Okay, next is to look at about the mode and median for continuous random variable. Okay, so first thing is the mode. Okay, mode is where the probability density function, which is the function fx, has the highest value, which is the peak of the graph, or the maximum point of the graph indicates the mode of the data lah, okay, of the random variable. And then the median is the value when the probability is equal to 1/2. Okay, now let's look at an example. Okay, let's say if we have this function, probability density function fx equal to 1/4 for the region between 0, x less than 1, and then x/2 for the region between 1 less than x less than or equal to 2. Okay, so now we want to find the median and the mode for this probability density function. Okay, so based on what we have is we have a value which is 0, 1 and 2. Okay, so given that the probability in between 0 and 1 is 1/4, then the probability in between 1 to 2 is x/2. Okay, so to find the mode is actually we have to substitute each of the value of x into its particular function and determine which one has the highest value. Okay, since region between 0 and 1 cannot be substituted into the function because there is no x in the function given, only 1/4. So for this one, if we substitute 1 into x/2, it will be 1/2. And if we substitute 2 into x/2, it will be 2/2. So this will be equal to 1. So we can say the mode is equal to 2. Okay, the mode is equal to 2 because when we substitute 2, it has the highest probability density function value. Okay, so that is how we know the mode is equal to 2. Then for the median, okay, the median we just take the probability of x less than or equal to m equal to 1/2. Okay, so for this one we just take 1 until 0, 1/4 dx. Okay, so we have to include 1/4 because since for region from 0 until 1, the probability is only 1/4. So since the median must be 1/2, so the median must be placed somewhere in between 1 and 2. Okay, we want to find the total probability is 1/2. So integrate from 1 to 0, 1 divided by 4 dx, plus from m until 1 for x/2 dx equal to 1/2. Okay, this is for the probability equal to 1/2. Okay, then we just integrate first x/4 10 plus x squared over 4 m1 equal to 1/2. So we have 1/4 plus m squared over 4 and then minus 1/4 equal to 1/2. So that left us with m/4, m squared over 4 equal to 1/2. So m squared equal to 2. So m equal to positive and negative of square root of 2. Okay, so since our function, okay, placed only in the region between 0 until 1 and until 2, which is only the region of positive region, and then our relevant value for median is equal to positive or square root of 2. Okay, because a negative square of 2 is a negative value, means it will be placed somewhere behind the 0, so that is out of our function punya region. So that's why the answer, the valid one, will be the positive. Okay, now let's look at about cumulative distribution function. Okay, cumulative distribution function is indicated with the letter of capital F and T inside the bracket, which means the probability of x less than or equal to t, which also equal to the integration from t until negative infinity of the probability density function fx dx. Okay, in term of graph, okay, in term of graph, so this is the graph, this is the curve of the probability density function. Okay, if we have the point of t right here, so if we say f, capital F t, so it will covers up all of the region from t until negative infinity of the function fx dx, which means the negative infinity until the t. Okay, all of the region on the left side of the graph, on the left side of the point of t. So that is the what meant by the cumulative distribution function. Okay, so if we have a probability which says a region in between a less than or equal to x less than or equal to b, okay, so it will be equal to the integration from point b to a for the probability density function fx dx, which means we want to find the okay, we want to find the probability in between the point A and point B. Okay, so this is the probability. So other than doing the calculation of integration from point A to point B, okay, it could also be done by doing the calculation of cumulative distribution for point B minus with the cumulative distribution for point A. Alright, because it will still give you the same value as the integration from point B to point A. Okay, what is meant by here? Okay, let's say if we are doing for the cumulative distribution function for point B, so that covers up all of the region from the negative infinity until the point of B. Okay, so this is for cumulative until point B. Meanwhile, for cumulative until point FA is from the negative infinity until the point of A. So this is FA. So if we take FB minus with the FA, so it will be equal to the probability in between A less than X less than or equal to B. Okay. Okay, now let's look at an example from the reference book on how to find the cumulative distribution function. Okay, here is the probability density function where we have a few regions from 0 to 4, 4 to 6. Okay, so firstly let's draw a line. Okay, so we have from region 0 to 4 and from 4 to 6. Okay, so the probability density function is 1 over 12x, and then the other one is negative 1 over 6, 1 over x plus 1. Okay, so firstly to find the cumulative distribution function, we must start from the left. Okay, we must start from the negative infinity, so we move on, we move until we reach to a point of 0. Okay, so which means we start with x less than 0. So the probability, the cumulative distribution function with capital F, x will be equal to integration, okay, somewhere less than 0. Okay, so we indicate that with a point of x, somewhere less than 0 until negative infinity. Okay, so in the probability density function given, the other region is equal to 0. The otherwise is 0 dx. Okay, so even if we integrate, it will give you equal to 0. Alright, so that is for the first region. Okay, then next is we move on to the next region, which is the region from 0 until from 0 until to the point of 4. Okay, we stop it right there. So that is for 0 less than or equal to x less than 4. Okay, so for that one, the cumulative distribution function fx will be equal to the sum of the probability of x less than or equal to 4, which is the sum of the probability less than 0, which is the first region that we did in the green colored marker one, and then the region in between 0 to 4. So that will be the integration in between probability of x less than or equal to 0, less than or equal to 0, plus with probability of 0 less than or equal to x less than equal to 4. So that is the 0, which is the one that we already calculated right here. So 0 plus with the new one, which is the from x to 0, okay, any point which is less than 4, we replace that point with the symbol of x until the point of 0 in between this region. Okay, but we didn't put 4 because it doesn't include number of 4. Any point less something that is close to 4, so we didn't have any exact value, we replace that with the symbol of x. Okay, then the function is 1 over 12 x dx. So that is equal to 0 plus x square over with 24 x 0. So it will be equal to x square over with 24. Okay, then we proceed with the next region, which is from 4 until 6. Okay, for region x is less than 6, x is bigger than or equal to 4. The cumulative distribution function will be equal to the probability of x less than or equal to 0 plus the probability of x less than or equal to 0 less than or equal to x less than or equal to 4 plus with the probability of 4 less than or equal to x or less than or equal to 6. So as calculated before, so right here is equal to 0 plus, so probability of 0 until 4 is 4 until 0, which is 1 over 12 x dx, and then plus with the integration of x until 4 of negative 1 over 6x plus 1 and dx. Okay, the 0 part comes from right here, which is the probability is will be equal to 0. And then, so 1 over 12x is in between 0 to 4. So we have to integrate that. And then what we are currently looking is the region in between 4 until the point of x. Somewhere about right here. So the integration will give you 16 over with 24. Sorry, I skip a part, so it should be x squared over 24. 40 plus with negative x squared over 12 plus x 4. So equal to 16 over with 24 plus with negative x squared over 12 plus x plus 16 over 12 minus 4. Okay. Alright. So the answer will be the negative x squared over 12 plus 8x plus x minus 2. Okay, so that is the cumulative distribution function for the region 4 is bigger, x is bigger than 4, less than 6. Okay, then for x is bigger than or equal to 6, okay, right here, beyond equal to 6, we already know the cumulative distribution function will be equal to 1, because that summarizes the total up all of the possible probability in the graph. So for the final answer for the cumulative distribution function, we rewrite it back as fx equal to, okay, for the first region we obtain 0 where the x is less than 0, okay, and then we obtain x squared over 24 where the region 0 less than or equal to x less than 4, and then we obtain negative x squared over 12 plus x minus 2 for region 4 less than or equal to x less than 6, and then for total we have it equal to 1 for region x is bigger than or equal to 6. So the bracket should be longer. Okay, so that is the answer for the cumulative distribution function. Okay, so next is to sketch graph of probability density function and cumulative distribution function. Okay, firstly let's sketch for the probability density function, which is the fx. Okay, so the graph of fx, we can separate it into two parts. Graph starts from 0 until 4 and then ends at 6. Okay, so as we can see, this equation x to the power of 1, which is the linear function, so we just substitute. So we know it's a linear, so the graph should be a straight line. So we just substitute 0. Okay, substitute 0 into the function. So f0 equal to 1 over 12 multiplied with 0, we have it equal to 0. So it starts at 0 and ends at 4. So it means we substitute 4 equal to 1 over 12. 4 equal to 3 over 4. Okay, sorry. Apa pula 3 over 4? 1 over 3. Okay, 1 over 3. It means our graph starts from 0 until 4 right here with a hollow circle, means 1 over 3. So here go the graph. Okay, then for the second region, from 4 to 6, we substitute f4 equal to negative 6, negative 1 over 6, 4 plus 1. Okay. So that one is equal to 5 over 3. Oh, sorry, not 5 over 3, but actually 1 over 3 because it's a negative right there. So it will be equal to 1 over 3. So 1 over 3 right here. And it goes down to f equal to 6. So f6 equal to negative 1. 6 divided by 6 plus 1. So right here is equal to, so negative 1 plus 1 is equal to 0. So here will be the 0. So this is the graph for the probability density function. But don't forget to label the x and y axis. And then next, for the graph for cumulative distribution function, same thing. Firstly, draw the axis, the fx and the x. Okay, for the cumulative distribution function, we have a region from 0 to 4 and to 6, and then go beyond of 6. Okay, so firstly we start with the 0. So we substitute 0 already at 0, and then we put f0. So it will be the 0 square over 24 equal to 0. So right here is 0 lah. So then we go f 4. So 4 square over with 24 is equal to 2 over 3. Okay, so right here is the 2 over 3. Okay, but don't forget, the equation is actually x square over 24. So it's actually a quadratic equation. So you have to draw a curve for a quadratic equation. Okay, and then for the next region, we substitute f4, but with the different equation, x square. So 4 square over 12 plus x minus 2. So this one also equal to 2 over 3. Okay, equal to 2 over 3. And then the f6. Okay, f6, we substitute negative 6 square over 12 plus 6 minus 2. So for this one, we have it equal to 1. Okay, equal to number 1. So 1 right here for f6. So this is also a quadratic, but a negative quadratic. So it forms a set curve, something like that lah. Okay, until the point of 1, and then you have to go a straight line for the region where the x is bigger than or equal to 6, where the function is equal to 1. So that is actually the curve for cumulative distribution function. Okay, next is to determine the mode. Okay, mode is determined from the graph of probability density function. Okay, this is the graph of probability density function. As we can see, the peak point is the 1.3, so the x is equal to 4. So we can say the mode is 4 lah. Okay, so that is for the mode. And then for median, okay, median, we know that the probability to find median, x must be less or equal to m equal to 0.5. Okay, so means the cumulative distribution function for m must be equal to 0.5. But what we have is actually the value for, the equation for the cumulative distribution function, which is the 0, x squared over 24, and then the negative x squared over 12, minus 2, and then 1. So this is for the region x less than or less than 0. This is x less than 4, bigger than or equal to 0, x less than 6, bigger than or equal to 4. Right here is for x is bigger than or equal to 6. Okay, so when the f4, okay, when we substitute 4 into the cumulative distribution function, we already obtain a value of 2 over 3. Okay, value of 2 over 3 right here, which already exceeds the 0.5. 0.5 is somewhere about here, so 0.5 must be somewhere the value in between this region from 0 to 4. So our median is a value that is located in between 0 and 4. So we can focus on the equation of x squared over 24. So we just take the x squared over with 24, or we can just straight away substitute the letter x with the letter of m and make it equal to 0.4. Sorry, 0.5. So we want to find it equal to 0.5, and we can have m squared equal to 25 multiplied with 0.5, and we have it equal to 12. So m is equal to square root of 12. So m is 3.464. So that is the median for the data that we have.